Consider the reaction N2 gas plus 3H2 gas yields 2NH3 gas. Suppose that at a particular moment during the reaction, molecular hydrogen is reacting at a rate of negative 0.0820 molar per second. At what rate is ammonia being formed? So, since hydrogen is a reactant, its rate is designated, and its rate will be negative 0.038 molar per second, and that's the rate of hydrogen. The stoichiometry of the reaction dictates that for every 3 moles of molecular hydrogen consumed, 2 moles of ammonia are produced. Therefore, the following factor can be used to convert from hydrogen to ammonia. And we can derive the following rate expressions from the balanced equation. And that equation is going to look like this. 1/2 times the change in the concentration of NH3 over the change in T is equal to negative 1/3 times the change in concentration of H2 over the change in T. And these fractions are coming from the coefficients. So the 1/2 is coming from the 2 that's in front of the NH3, and the 1/3, or the negative 1/3, is coming from the reactant side of where 3 is in front of the H2. So this new equation is going to look like this. Delta NH3 over delta T is equal to X times delta H2 over delta T. And delta T is the conversion factor. And like how we said earlier, for every 3 moles of molecular hydrogen consumed, 2 moles of ammonia are produced. So that right there, that tells you what your conversion factor is going to be. But it's also going to be negative since it's on the reactant side. So the conversion factor is negative 2/3. And so using this, you can convert to ammonia. So delta NH3 over delta T is equal to negative 2/3 times negative 0.0820 molarity per second. Remember, that's your rate of hydrogen. And that is going to come out to 0.0547 molar per second. And that is the rate at which ammonia is being formed.